This is the Incrediplotter. Let's do it. Draw an astronaut riding a horse. Well, it shifted the paper a bit. This is the Incrediplotter. It can draw anything you tell it to. The machine is made of reused parts from an old Ender 3 3D printer. 3D printed plastic pieces are used to hold things together, and they were designed in Onshape. The flare pen is held in with a set screw. A servo motor lifts it up, but it's pushed down on the paper just by gravity. All of that mechanical stuff was done by my brother. I did the electronics and software. Here a microcontroller is running a popular 3D printer firmware called Clipper, and my computer is running the Clipper app. The computer is also running Moonraker and Mainsail, which lets me control the Clipper stuff from my browser and from code. I have a Python program running on the computer that just acts as a bunch of glue code. It uses a transcription library called Whisper, and that takes what I say and turns it into text. That text is then put into a prompt. That prompt is then sent to Google Gemini through an API. It generates an image and sends it back. My program takes that image, does some filtering, and turns it into an SVG vector line drawing using a program called Autotrace, specifically with something called centerline tracing and not just normal tracing. That line drawing SVG is then converted to G-code using a program called vpipe G-code. And finally, we have G-code that Clipper can accept. My script sends this to Clipper using the Moonraker API and then tells it to start printing. My brother and I started with a broken Ender 3 which we took apart. We saw that the materials were worth keeping to use for projects. A bunch of aluminum bars, motors, wheels, belts, and more. So we thought a pin plotter would be fun to make. But figuring out where to even start with the mechanism was difficult. But with enough time, you can figure it out. You can do a lot of things with just using a motor shaft to move a belt that pulls a carriage that rolls along the rail with the wheels. And well, this is how the X and Y axes of the Ender 3 work anyways. Adding a second axis was really hard, and there's lots of ways to do it. The one we went with isn't ideal for speed or weight, but it was the easiest to construct and pretty easy to understand. We used 3D printed parts to hold the motors in line with everything else, and at first we thought PETG would be better since it's tough, but it was too flexible, so PLA worked out better. So as soon as you have something where you can just use your hands to twist a couple of knobs to position the pen anywhere over the paper, that's when you can start driving the motors to do it automatically. So to drive it, I had to learn how stepper motors work. All I knew was that there's 4 wires coming out and the 3D printer knows where the motors turn to, so I figured, well, they must be ground, high power, logic power, and data. But that's not how it works at all. Really, these are all power wires in a way. They just need to be turned on in the right order in a certain manner so that it completes one step at a time. When I saw this clip on YouTube, it all made sense. Since these steps need to be done with high power wires, I can't just hook it up to a microcontroller directly. This is what a stepper motor driver is for. It takes in a relatively high voltage and uses that to control the stepper motor directly, while on the other side of the board it exposes step and direction pins, which are a really easy interface for the microcontroller to handle. What's cool is that there's really no sensors involved. All the microcontroller code has to do is send step signals and just count them and keep track. Using that, it can just guess where the motors turn to and it's completely accurate. The stepper motor driver I used is a TMC2208. These are like twice as expensive as the ones in the Ender 3, but I chose them because they make the motors way more silent, which I think is surprising that just with the electronics, a loud motor can become quiet. On this thing there's a lot of pins, but I could just ignore half of them if I don't care about microplier and stealth chop 2 and spread cycle. What I did need was to screw the potentiometer on it to the right amount so it would limit the current, basically limiting the strength of the motor and limiting how much power it can draw from my supply. I saw some YouTube video that explained how to do this. So with this, I started off by putting one of these motor drivers on a breadboard and using it with an Arduino to spin one motor around. After that was working, I started designing a perf board circuit that would control both axes. This way it would be a lot more compact and sturdy than using breadboards. I planned it out in an image editing software, where I decided to use an STM32 Blue Pill because I got a bunch of them for cheap and I wanted to try out the brand. Picking which pins on the microcontroller to use was challenging. I wanted to pick pins that supported the timer peripherals just in case I needed them. I also needed to account for the limit switches and the servo, which definitely needed a pin that was compatible with the timer. And once the circuit was all planned out, I could start soldering everything together while looking at my picture for reference. Instead of soldering the stepper motor driver boards and microcontroller board directly to the perf board, I used female pin headers. This is so if one of the components fails, I can just pull it out and replace it. It was also important to make sure everything had a common electrical ground, which I almost forgot. And after a lot of painful soldering later, it was finally ready. So then I looked into what software this microcontroller should run. Soon I found out that I should have done this way earlier. But the key to finding existing software I could use was the realization that my pen plotter was basically just a CNC machine, but with a pen instead of a spindle. So I discovered the GRBL software, which is what people use when they make an Arduino-powered CNC machine. Or Gerbil HAL, which is an upgraded version of it. There's also Fluid NC for ESP32 microcontrollers. I saw that there were already so many board designs just like what I did. I felt kind of bad. I ran into compatibility issues with all this existing software. The closest I got was this Gerbil board that supported my chip, but it required the motors and limit switches to be wired up to particular pins that I didn't have them on. And I really didn't want to resolder anything, so I decided I might as well try writing my own software for it. To start with, I was disappointed to find that I had to buy an ST-Link programmer, instead of just programming this thing over the USB port like all my other boards. For how popular these STM32 chips are, it took me a long time to get going with just blinking an LED and accepting input through the serial port. Even just setting up the clocks took way more research and time than I thought. The Eclipse IDE sucks, and the code generation is weird. So for a while I was really not liking it. I was wishing I just used an ESP32 with Fluid NC, but I had to keep moving. To get both stepper motors moving to a target, I set up one of the microcontroller timers so I could have a function that runs like 1,000 times per second. I call this my periodic function. In the code I made two XY position variables, the current position and the target position. In the periodic function, each axis positions would be compared to their targets, and if they were not equal, it would generate a step signal very briefly in the correct direction. Later I made it so I could send a couple numbers from my computer and the machine would set that as its target position. That way I could control where it goes from my computer. I had a cool idea to use an LLM to generate a JavaScript web page UI to do it using WebSerial, and that worked great. Then, after making the pen lifting servo motor work, I made the microcontroller accept another serial command that lets me lift and lower the pen. And finally, this is the point where the machine could actually draw something. So I came up with a simple drawing that I could try entering commands manually with and see what happens. Here's how it came out. My code indeed got the pen from one position to the next, but it doesn't do diagonal lines very well. The algorithm needed to be more complex than I wanted. Oh well. I was having a really hard time finding any resources on how to write such a thing, so I decided to make a Python script where I would just practice this very easily. This made the trial and error process a lot quicker. So once I had it down, I did the C code for it on the microcontroller, and it worked great, and the test drawing looked much better. Then I came up with a plan to have the microcontroller draw automatically. Instead of me entering all the numbers in manually, I would send them all up front and then have the microcontroller go run what it stored. Since G-code looks really inefficient and the microcontroller needed to store these drawings, I came up with a little instruction system that would keep the commands really small in memory. After trying out this command storage system out manually, I figured I wanted a better way to generate these lists of bytes for the drawing. That's when I found out about this website called LaserWeb4, which lets me drop in any picture and convert it to G-code. Then I told AI to make a script that would turn the G-code into my own format, which I could then enter into the web UI and have it sent to my microcontroller, and it worked great. It was really cool to see it draw something from its internal memory by itself. But the drawings looked really bumpy and weird. I guess before I thought the millimeter precision was enough, but it wasn't. So instead of taking each coordinate as 1 byte, each coordinate takes 2 now. After doing this, it was way smoother. So at this point, I thought of what the next steps were. For one, I wanted it to do more complex drawings, but that would use up more storage space than what could fit with all the other stuff in the 20 kilobytes of RAM this thing has. I had an idea to take in one part of a drawing at a time from the computer and then store it in flash memory, which would serve as a kind of hard drive. Also, I wasn't liking the machine's movement. It was jerky and slow. I could make it faster by making the periodic function run more frequently, but then it would be even more jerky, so I should make it accelerate and decelerate when drawing a line. But drawings are made of many tiny lines, so that wouldn't work. Well, I came up with a good algorithm for this in my head, but actually implementing all this was going to take way too much work, and then before I knew it, this fun project would turn into months of grueling work. Then all of a sudden, I found a great shortcut. I was reading on Hacker News about someone's custom 3D printer firmware. One commenter had me looking at the clipper and I learned how that works. The computer sends rudimentary step and direction commands, and all the microcontroller does is very simple control of the motors. This way, Clipper on the computer would do all that complex drawing, storage, and motion stuff that I wanted to see. This sounded like it would be easy to give a try. So I set up Clipper on my computer using WSL, using a very nice install script I found. The setup went very smoothly. I thought I would have to write my own Clipper command parser for the STM32, but luckily my exact model of microcontroller was already included, and it was really easy to install. So then, with Clipper and its web UI installed, I could just open up my browser to localhost and see it. Part of what makes this so easy is that in order to define what pins my motors and switches are on, all I have to do is write what they are in this printer configuration file and save it. This makes it really easy to change without reprogramming the microcontroller every time. In order to actually see and control the microcontroller stuff in Clipper, I had to use USB IPD and PowerShell. And finally, I set up some custom G-code macros for lifting the pen up and down. I also glued down some limit switches so Clipper could home the machine. I crashed the machine a few more times trying to get the conversion factor right, but I got it. So with all that set up, now in LaserWeb 4 I could generate G-code for a drawing, and then I could drag and drop it right into Clipper and hit start, and it would start printing. This was brilliant and let me see the machine use its full potential. It was very cool. I wish I would have found this Clipper stuff earlier, but it was also cool to learn the basics of motor control on my own. It's neat that thanks to Clipper, people can just build 3D printers all by themselves and not have to code anything. I also found this software called DrawingBot, which lets me drop in any photo and turn it into a G-code of a stylized, scribbly looking thing. So as happy as I was with all that Clipper stuff, it still just wasn't very fun to use. I had to spend a lot of time finding the right picture and doing the right method of converting it to a vector and G-code and all that. On top of that, when I dropped stuff into LaserWeb 4, it would just cause the pen to lift up and down between every little line segment, which was awful. Then I got an idea. What if I made something where I just tell it what to draw, and it would just draw it magically? This was brilliant, and let me see the machine use its full potential. It was very cool. I wish I would have found this Clipper stuff earlier, but it was also cool to learn the basics of motor control on my own. It's neat that thanks to Clipper, people can just build 3D printers all by themselves and not have to code anything. I also found this software called DrawingBot, which lets me drop in any photo and turn it into a G-code of a stylized, scribbly looking thing. So as happy as I was with all that Clipper stuff, it still just wasn't very fun to use. I had to spend a lot of time finding the right picture and doing the right method of converting it to a vector and G-code and all that. On top of that, when I dropped stuff into LaserWeb 4, it would just cause the pen to lift up and down between every little line segment, which was awful. Then I got an idea. What if I made something where I just tell it what to draw, and it would just draw it magically? At first, this sounded unrealistic, it was just a joke. But, as I thought about it more, it seemed pretty easy to do. I would just have AI generate a picture. At first, I tried just having it run on my own computer. It was quick enough, but it just wasn't reliable at giving me things that a pen plotter could actually draw well. There were too many details and big filled-in areas. So I looked into alternatives, one of which was Google Gemini, which followed my prompts much better. I found out I could do this in code using their API for free. I can't believe this is free, and it's just as fast as my own computer, and the images are a lot higher quality. This is why I feel like this idea has only really become feasible in the past year or two. So from then on, I did all that stuff I mentioned at the beginning of the video, and yeah, it works great. The hardest part of all this was finding something that could turn a picture into a vector line drawing. I had to look through GitHub issues, comments, and pull requests to find a specific old version of AutoTrace that worked on my computer. One thing I tried to do in my Python code was to have the computer make some remark about your request while it's waiting for the picture to be generated. This would fill in the dead space between your request and the start of the drawing.
Draw a screaming jelly bean.
Screaming jelly bean sounds like my dentist's dream and my sugar-addled nightmare. Buckle up, we're in for a vibrant, possibly gelatinous, ride.
It did fill that purpose very well, but it got kind of annoying, so I turned it off. As for the interface, I wanted to make it so you could just say, computer, draw, blah blah blah, and it would do it. No button presses involved. I got the wake word part working for that, so you could say computer and it would start listening, but the next obstacle would have been to make the computer stop listening automatically. But that would have been a whole nother ordeal. So I just stuck with a button press since that was easier. Additionally, only around this point did I realize that for the electronics, I could have just used the control board that came with the Ender 3. That would have saved some time. But in the end, I am pretty happy with how this turned out. It's a weird feeling to put together a machine that can draw anything you tell it to, and yet the problem is, I just don't know what to tell it to draw. I don't really have any good ideas. But I did learn a lot of cool stuff making this, so I think it was well worth it. Next up is the Incredicalculator. That's all. Bye-bye.